morning students. In chemistry practical, we have three experiments. First one volumetric analysis, second one inorganic salt analysis, third one organic functional group analysis. So first we will start from volumetric analysis. For volumetric analysis, we need three reagents. First one unknown K1O4, second one ferrous ammonium sulfate already prepared, so you no need to prepare. And third one dilute sulfuric acid. So all three reagents already kept in the rack, so no need to touch anywhere. Okay, so first you have to fill burette using unknown K1O4. So before we fill, first rinse the burette clearly. By using funnel, you fill carefully K1O4 up to 0 level. Okay, now you can see the bottom area also filled. So now it is equal to 50 ml. So now place the burette on this stand, and we need some space for titration purpose. Second thing, take conical flask. We have to take 20 ml ferrous ammonium sulfate FAS, and the 20 ml we have to pipette test. Okay, so take 20 ml pipette. So we have to pipette 20 ml. By using your index finger, so here we have a mark, so slowly release up to this mark. Okay. So now pour this 20 ml ferrous ammonium sulfate into a clean conical flask. And also add one full test tube of dilute sulfuric acid into this conical flask. So add one test tube full of sulfuric acid into the conical flask. So now we have two reagents in this conical flask. One is 20 ml ferrous ammonium sulfate, another one test tube full of dilute sulfuric acid. So now we have to titrate against K1O4. So we have to use only left hand to control the burette and right hand to shake the conical flask. So slowly release. Now the solution is colorless, but the endpoint will be pale permanent pink. Now you can see this is the pale permanent pink color, and check the burette reading. It is 19.1. So you can repeat 2 times and note down the values and do the calculation. Clear? So from this experiment you can find the molarity of KMnO4 and strength of unknown KMnO4. Yes, so first experiment over. Now we will move to second experiment. Okay, second experiment, salt analysis. We have 7 salted, so we will do only confirmed test for both cation and anions. So first salted, number 1 is mentioned, the salt is lead nitrate. So we are going to test for lead separately and nitrate separately. So you take test tube and with the test tube handle. Okay. Add small amount of salt into the test tube. Dissolve with water. Now add potassium iodide solution. Just a few drops is enough. So yellow precipitate will appear, which confirm lead. So you see it turns into yellow precipitate, so which confirm lead. And for same salt you have to confirm nitrate also. So similarly you take small amount of salt. Again dissolved with water. And now add freshly prepared ferrous sulfate. So for this you have to prepare ferrous sulfate freshly. So take another new test tube. So take ferrous sulfate, small amount, dissolved with water. So now freshly prepared ferrous sulfate is ready. So this freshly prepared ferrous sulfate you add with your salt. So you see white precipitate is appeared. Now you have to add few drops of concentrated sulfuric acid very carefully, because it is a very concentrated acid. You will get brown ring. Add along the test tube very slowly. So you can see the brown ring is appeared, which confirm nitrate. Now we confirm lead and nitrate. So your salt is lead nitrate. So salt number 2, ammonium sulfate. So we will do same, one test for ammonium, another test for sulfate. Take a fresh test tube, take a salt small amount, dissolved with water. Okay, now add sodium hydroxide and Nessler's reagent. You will get a reddish brown precipitate. Sodium hydroxide, small amount of sodium hydroxide, and Nessler's reagent. Nestler's reagent. So you will get reddish brown precipitate, you can observe. So once the drop enter the solution, reddish brown precipitate starts to appear. Okay. So which confirm ammonium cation. Okay, next we have to confirm sulfate also. So for this, take a new test tube. Again add the salt. Dissolve with water. Now add dilute HCl and barium chloride solution. You will get white precipitate. So dilute HCl 4 to 5 drops. And barium chloride solution. You will get white precipitate. Okay, you can see white precipitate appears. So which confirm sulfate. So we have ammonium cation and sulfate anion. So salt is ammonium sulfate. Okay, next move to third salt, calcium carbonate. So we have to confirm both calcium separately and carbonate separately. So take a test tube and take your salt number 3. Again dissolved with water. So calcium alone, once you dissolve with water, the white precipitate will be appear. So in this stage you can confirm which is calcium. And if you add ammonium hydroxide and ammonium oxalate, again the white precipitate will be remain. So ammonium hydroxide and ammonium oxalate, white precipitate will be remain. So which confirm calcium. So calcium alone you can confirm once you dissolve with the water. Okay, next carbonate we have to confirm. So again take salt. Dissolved with the dilute HCl, you will get brisk effervescence due to carbon dioxide gas release, which can form carbonate. So add dilute HCl. You can see the brisk effervescence due to the carbon dioxide gas release. So now we confirm both calcium and carbonate separately. So our salt is calcium carbonate. Okay, next fourth salt, aluminium nitrate. So salt number 4. aluminum nitrate, first we are going to confirm aluminum. Take salt and dissolve with water.
Add few drops of aluminum reagent. You will get bright red lake, which confirms aluminium.
Nitrate, I think we already completed. Brown ring test. In salt number 1, lead nitrate, we completed the brown ring test. So you check it. Okay, next we will move to another salt, salt number 5. Salt number 5, ammonium chloride. So we have ammonium cation and chlorine anion. So again, ammonium test is the reddish brown precipitate. If you add sodium hydroxide and Nestless reagent, you will get a reddish brown precipitate. So already we completed. And move to anion chlorine. So take salt number 5. So small amount of salt number 5. In salt number 5, we have to add MnO2, manganese dioxide. So first dissolve small amount of water. Add MnO2, manganese dioxide. So MnO2 is very black color powder. We add small amount of MnO2. So next, concentrated sulfuric acid. You will get greenish yellow gas will be evolved. That is chlorine gas. So concentrated sulfuric acid. So add carefully. So you can see the greenish yellow gas is evolved, which is chlorine gas. So we can confirm chlorine anion. So a salt is ammonium chloride. Okay, next is salt, ammonium carbonate. So again ammonium test is the reddish brown precipitate. If you add sodium hydroxide and Nestless reagent, you will get a reddish brown precipitate. So already we completed. And move to anion, carbonate. So carbonate also just now we completed. MnO2, dilute HCl, you will get brisk effervescence. The carbon dioxide gas will evaporate. So which confirm carbonate. So the sixth salt already we completed, both cation and anion separately we completed. So you check it. And we'll move to seventh salt, magnesium sulfate. So salt number 7. So take small amount of salt and dissolve with water. Now add magneson reagent. You will get blue precipitate which confirm magnesium. Okay, so magneson reagent. You will get blue precipitate. So you observe. Okay, it is blue. So you will get blue precipitate. Yes. So blue precipitate. So which confirm magnesium. And we have another one, anion sulfate. So for sulfate, again take same salt, small amount. So salt and dissolved with water. Now add dilute sulfuric acid. Dilute sulfuric acid. Then barium chloride solution, you will get white precipitate. So barium chloride solution. Barium chloride solution, you can add directly barium chloride salt, or the solution we prepared, you can add this barium chloride solution also. Okay, you will get white precipitate immediately. So which confirm sulfate. So we confirm magnesium cation and the sulfate anion. So our salt is magnesium sulfate. Clear? Next experiment, organic functional group analysis. So we have 5 functional group. First one alcohol, second one phenol, add one aldehyde, fourth one ketone, fifth one carboxylic acid. So first we will see alcohol confirm test. So add small amount of alcohol. And an algal confirm test, you have to add sodium metal, small piece of sodium metal. So sodium metal, you can cut by using a spatula. Take a small piece of sodium metal. You will get the bubbles. Okay, the brisk effervescence due to hydrogen gas release. Okay, you can see closely. The bubbles are formed. This is due to the hydrogen gas release. But you have to be very careful. Sodium metal is very highly reactive with water. So before you use sodium metal, you have to dry everything. So small piece of sodium metal is enough. You will get the effervescences due to the hydrogen gas release. So which confirm alcohol. And the second functional group, phenol. So phenol, we have to do ferric chloride test. So phenol also reactive to skin. So carefully add small amount of phenol into the test tube. Ferric chloride test, you have to prepare freshly prepared ferric chloride. So ferric chloride is a salt. You have to dissolve with water. Take new test tube. Add small amount of ferric chloride salt. Dissolve with water. Now freshly prepared ferric chloride is ready. Now add this freshly prepared ferric chloride into your phenol compound. Add 1 or 2 drops alone. Sometimes you will get green color, sometimes blue, or sometimes violet color will appear, which confirm phenol. The violet color, yeah, now we will get violet color. So if you dilute, the violet color will be easily visible. Okay, you see the violet color is visible. So the violet color, okay, you can see the violet color. Okay, yes, so which confirm phenol. And the organic compound number 3, aldehyde. So aldehyde you have to do two confirm tests. One DNP test. DNP test for both aldehyde and ketone. So take compound number 3. Yes. So organic compound 3. Now add 3 ml of 2,4 DNP solution. Yes. So 2,4 DNP solution. You will get orange yellow precipitate. See? So you will get orange yellow precipitate around here. So orange yellow precipitate, which confirm aldehyde or ketone. So this test for both aldehyde and ketone. So you cannot confirm aldehyde or ketone. So next you have to do test for aldehyde alone. So which is tolerance reagent test. Tolerance reagent test. First you take tolerance reagent in test tube. So small amount of tolerance reagent. Then you add your number 3 compound aldehyde. So you will get white precipitate, and this white precipitate you have to heat in water bath for 10 minutes. You will get silver mirror on the walls. Is on, so water is filtered. So if you heat for 10 minutes, you will get silver mirror. You see silver mirror is appeared on the walls. Okay. So if you clean the test tube, the silver mirror is clearly appear. So which confirm aldehyde alone. So the previous DNP test for both aldehyde and ketone, this tolerance reagent test only for aldehyde. So now aldehyde is confirmed. Suppose DNP is answered, but aldehyde test is absent, means which is ketone. But we have a separate test for ketone also. So take test tube. So ketone will answer for DNP test first. Okay. So suppose ketone student, you have to do DNP test first. Then, so your compound number 4, small amount of your ketone compound into the test tube. Then add 1 crystal of sodium nitroprusside. So just 1 crystal of sodium nitroprusside. So small crystal is better. Then add sodium hydroxide. Sodium hydroxide solution. So you can see the solution turns into red. So which confirm ketone. So for ketone you have to do 2 tests, one for DNP, one is DNP and another one sodium nitroprusside test. 5 carboxylic acid. So small amount of your compound, then add sodium bicarbonate salt. You will get brisk effervescence due to the carbon dioxide gas release. Okay, sodium hydrogen carbonate salt. So you can observe, you will get brisk effervescence. So So you can observe the small bubbles are released. So the bubble formation is due to carbon dioxide gas from carboxylic acid. So which confirm carboxylic acid group. Okay, thank you.